Hello class, this short little lecture is going to remind you or introduce you to the concept of spatial joins in geographic information systems. Alright, so the first thing we need to cover is what is a spatial join and what does it do? What it does is it allows you to combine attribute information from one layer to another based solely upon the spatial location of each data set. The only thing in common that two pieces of data need to have is that they share geographic space. A spatial join does create new data. It creates a new data set that represents whatever summary or attribute grab it was that you were wanting between the two data sets. There are lots of different options available with spatial join, and the options that you get are driven by the geometry shape of your data sets. So if you're working with polygons, points, or lines, and then any combination. So if you think there's three different types on either side of two data sets being spatially joined, so you have about an option of 9 different ways that you could be combining data. So lines to points, points to polygons, polygons to points. So all those different scenarios lead up to different questions. So what are some of those questions you could ask? Well, you could ask what polygon each point in another data set falls within. So what you would be doing is you'd be creating a new data set of points that has all of the original point attributes, but then each point is attributed by the polygon attributes that it falls within. So let's say you have an attribute data set of addresses, and those addresses just have their street address, right? That just has their street address, city, state, and zip. But you need to know what county they fall in. So if you have a data set of counties and you have your data set of points, you could do a spatial join from polygons to points and say, I want each of these points to be attributed by the values in the county data set. And then your output would list all of the points with all of the original data, but it would have additional fields now added based upon where that point landed and which polygon it intersected. You could also determine which polygon a line data set intersects. So attributing your lines by the polygon that they intersect the most. So if you're wanting to look at which streams fall within which watersheds, and you have 2 separate data sets, you could use your stream lines and your watershed polygons, and you could ask for each line which polygon does it fall within. And the output would be a new line data set, all of your stream attributes, but the polygon attributes, now all of your watershed name and whatever details you had about those watersheds, would now be a part of that new data set. You could also ask questions about summary. You could ask about counting things. So you could count the number of polygons number of points that were in each polygon. So let's say you have a data set of, you have a data set of conservation areas, and you want to know the number of endangered species in each of your conservation areas. We have your conservation area polygons, and you have your endangered species point locations. You could, with a spatial join, ask how many endangered species locations fall within each of my conservation area polygons. And the output would be a polygon data set, all the original attributes, with an additional field called count. And that count would represent the number of points from our endangered species data set that fell within each of those polygons. So those are just 3 of the probably list of about 10 to 15 different options that you would have with the tool. So now that you know what it does, where can you find it? Spatial Join, the tool, access to the tool, lives in 2 different locations. It opens up both locations open the same tool. You can get it to it directly through Arc Toolbox. It lives under the Analysis Tools and Overlay sub toolbox called Spatial Join, or you can get to it by right-clicking off of any of your layers in your map contents and going to Joins and Relates and selecting Spatial Join. And when you do that, it opens the exact same geoprocessing tool. So you're working with the same tool, just 2 different ways to get at it. And you'll notice that this is a theme with Esri products. They typically give us multiple ways to access tools, and the reason behind that is because as the Esri GIS software has changed over time, we've gained access to tools in different ways. It used to be that tools only lived on toolbars, and then tools only lived in right-click menus. Since about 2000, in the advent of ArcMap, most of those tools lived in Toolbox. But when they did that, they still gave us access to things off of right-click menus and toolbars as well, just because people who had worked with the software previously, that's where they were used to finding these things. So that's why you can find things in multiple locations. The beauty of Arc Pro is that it opens the same tool no matter where you find it. In ArcMap, if you ever go back to that and work with that and find tools in different ways, you'll notice that the screen that you get for the tool is slightly different. It's all running the same thing in the background, but the coding for the way that the form looks is different depending on if you pull it out of Toolbox or a toolbar or the right-click menu. So the people who programmed Arc Pro did a nice thing by just getting rid of some of that confusion, and when it really does open up the same process, the tool look is the exact same as well. So you'll see that's where the tool will open for you. So here we're just going to go through an example similar to what I talked about in a couple slides ago, but this is going to give you pictures and also screenshots of a made-up table that would go along with it. So let's say our scenario is that the Butler County Health Department needs to know the school district for every reported positive flu test. All right. So the data that you have are that you have address points of positive flu tests, and you have school district boundaries. So in this graphic over here, the rectangles are our school district boundaries, and the green points are our positive flu tests. So what the spatial join will do, since we're asking, because we need to know for every school district the number of, for every address, we need to know the school district that it belongs in. So what's going to happen here is that because the output information that we need the points with additional information. Okay, we need to know those points and then the school district they're in. And this would be so that they could contact the school district to let them know that they've had students in their district with a positive flu test. So those are our two data sets. When we do the spatial join tool, this is what the point attributes would look like. So for every point, we have an address. The information added is going to be our school district ID and then also our school district name. So notice that here for points 1, 2, 3, and 4 over here, we're school district C. We didn't know that before until we looked at it and ran the tool. And then for point ID 5, it's in school district E, and point ID 6, it's in school district D. So now for all of these addresses, we know which school district should be reached out to in order to share information. Now, you could also flip this on its head and count the number of positive flu tests within each district. So count the number of points within each polygon and update the attributes of the polygon data set. So let's see what that would look like. So when we do that, the scenario here now becomes that the health department now needs to know how many cases have been reported by each school district. So when we reorder the data sets that go into the tool, we can now say for each of our school district polygons, count the number of points that fall within it. So here we have all of our different school district names. Notice they only appear once, right? And then for each of these, we get a count of the number of positive flu addresses that are within each of those school districts. And we could really easily create a table or a graph that would show that clearly school district C is the one that's having the highest spike and the other ones are not doing all that bad. So that's one application where you could see between polygons and points how the spatial join tool works. It does not affect your geometry. What it does is it updates your table and gives you additional attribute information based from another data set based on spatial location. All right, so there's the spatial join short lecture. It is a nice bridge between our vector concept, our vector data and vector tools concept, and our tables concept, because it does pay attention to geometry. It is a vector overlay because they have to know where they live. But it also is only attributing your tables. You're not updating any geometry. Whereas our table functions, our table joins, and our table relates only work on the tables. They don't have anything to do with spatial overlay or where the geometry of the data sets live. So nice bridge, and next you're going to move on to the tables lecture.